So we're just gonna chill in 3D model basically. So we're just gonna chill until someone comes. Alright. Alright, now live streaming.
Did I stream?
Yeah.
Sorry about
No,
that.
it's okay, it's fine. There's no one here, and if someone does happen to come, it's fine. 21, so I'll do 0.5. Anytime soon, you know, someone's gonna hop on the stream and start chatting, theoretically. Now we will offset later, but let's see, like 5. Alright, and then we can repeat extrude this guy starting here, and then negative 0.5. Yeah. 5 mils. That's like quite a thin layer, but maybe we should have made it a little bit longer. Yeah, I'm gonna make it longer. And then we can do, because we want just do 40, and then these can be a bit different. So 33, 30. So 33 minus 7 is 27, and then give it 2, so 25. Okay. Inspect. 22. Should just do 2 mils. Oh shoot. New body. Okay. And now we just need to do some quick offsets. Yeah. And we'll offset later. Oh wait, I should save first. New gearbox. Marcus, you should totally join my live stream. Or not. Because we don't need them to be super thick and chunky. Offset. Oh, hello there. Somebody joined. How are you? Square shaft. Alrighty. We are just gonna be doing this stuff. Alright. And now we should start making gears. see how we're gonna do that. Gear generator, we're gonna do double helical. Module is gonna be probably like 1, and then 17 is fine. Blah blah blah. Okay. Like that. Actually, I do not want to do it like that. I'm gonna make it double helical. Like that. Just like that. Alright, now we gotta align. So, Control A for this. From here to here. Oh. Please work. This gets pretty horrendous sometimes. Let's turn off the sketch. Turn this off as well. Yeah, this is kind of annoying, but should be okay. Yeah, that's really not trying to work, but we'll make it work. We'll make it work out. Can I move? And then first I'll rotate. No, not like that. I want to move this individually. And no, that's not trying to work. Here, I'll probably create a new component. Oh, hello, one other person. How is everyone doing? Like this. So for the 2 people that are here with me, I'm trying to make a new gearbox because my old gearbox for my shredder, which is the main goal of this project, if you want to see right here, is to make like a fully 3D printed shredder. And this gearbox, you guys are gonna find like a normal video on it, but it like kind of worked, but it also didn't really work. So I'm trying to take some advice from my family and like change some things, tweak some things, and hopefully we'll be able to start shredding stuff. Because the problem was the shafts of the gearbox, it started slipping. So like as the gear started spinning, when you like, because it's such high torque, when you put some load on it, the shafts would bend, and because it's fully 3D printed, the gears would go away from each other, which obviously is not what a gearbox is intended to do. So here what I'm trying to do is a little bit of a different configuration, but the goal is to make it basically make it work. And all these files are going to be published on like printables or something like that, so you guys can have access to it. So right now we're just trying to make things work. Alright, so we want to capture. Actually no, I will just do that here. And we want this guy to be a little bit taller, so Shift O, and then we can offset it by 2 mils. Like that. And then what we can do is we can create another gear. This will be like that, and then we're going for either a 1:2 or 1:3 ratio. I'm gonna first test 1:3. So 17 times 3, that's 51. See how big that is. Because the thing about a 1:2 ratio, you're gonna need a lot more bearings and a lot more shafts to get a really high reduction. So obviously there's like a trade-off. So like it's less precise. But I think 1:3 is what we're going to go with. Yeah. So here, let's hide this. Oh my gosh. Move it first, and then we can. What am I doing? Oh, hello, people. There's 4 people on the stream. So let me ask you guys. Do you guys do Fusion 360, or are you just getting into it, or do you just like watching other people do it? Yeah, perfect. Let's go here to here. Alrighty. Okay, I'm assuming that's. No, that is not center at all. So we'll need to try again. Yeah. From here to here. Then we just need to show it. Sick. Yep. Hopefully this is good. Don't wanna mess things up, if you know what I mean. Yeah, that seems fine, hopefully. From here to here is 21. This was like 10 high. No. Alright. So, should be good. Perfect. Now we just need to just keep working. This design still has a long way to go. But let's just for simplicity, extrude here and then just 7. Like that. Alrighty. Now we just need to make more copies of this entire thing. So for the base, what I want to know is how much spacing should we give? No. We should know like how much spacing we want. Let's create another sketch. See. So 52, 53. Looks like 53 millimeters. And then the smaller gears are 20. No, probably 19. Yeah. Okay. So now we just want them to like mesh together. So we gotta do something like this. There is a formula for it, but I don't quite remember, so we can search it up. spacing here. Center distance. Okay. Number so 17. 1. 34. 34 mils. So like this, basically. Oh no, 53. Okay, yeah. Yeah, and then we can just make this a little bit more, so 53.15. Did that move it? Oh, we gotta constrain. Alright, that's already constrained. Yeah, I don't think that's doing anything. Oh, right. Because I'm not smart. Right, perfect. So now we have the general setup for the gearbox. Okay. Now we just gotta create the opposing side, which shouldn't be too bad. And soon we'll just have to make things work out. So C22 and then C8 because these are 608 bearings. Hello there. How are you? My one other special friend in this lonely live stream. Oh my gosh. Nope, that's not it. So we want 7. Okay. Let us just, or maybe if we just, instead of that, we just do a rectangular pattern.
Happy birthday!
Thank you.
Happy birthday!
Thanks, girl. So the spacing is 34. 34. Oh, shoot. Shaft number 34.15. Perfect. And now we just do another another rectangular pattern with this guy. Path is this guy. 5. And shaft number. Yeah, this is honestly going a lot faster because I'm using these parametric modeling. So, well, what I'm gonna do is spacing is 34.5. Okay. Now we just edit these to spacing. And then here we want edit is spacing. Perfect. Now we got all that set up. And then because of these guys, we want to create a pattern. Not that pattern with these gears. Well, first we want to combine these guys, of course. Into that. So alright. So now this guy is done because we combined it away. So this is just call it clockwise gear. And we're gonna label it 1 to 3 reduction. And then we're gonna do a rectangular pattern, but because of the way the gearbox is set up, we want it to be the spacing times 2. So this, and then I love Fusion for doing this, times 2. So then it's twice as long, and then for this, it'd be, usually it would be just the count, or number of, shaft number, and then you can divide that by 2. Because we are using, an even number of shafts, it's alright in this case. But if you had an odd number, I actually have no idea. Yeah, let's check that out. Just say 3. Yeah, and then you get a warning, and then you can manually. Is it possible to round? Maybe, I'm not very sure, but here, I'll just do a quick. Can you? Oh, okay, perfect. So it'd be floor. Nice. That's actually honestly quite helpful, because obviously you can't duplicate something 2.5 times, which is hence the error it's giving me. Should be divided by no times 2, and the quantity will be number like this, and then we had to do like floor parentheses shaft number. It's actually really cool. First time I've really heard of this. So floor shaft number divided by 2. Wait, no, it should be ceiling or seal. Seal? And that should give me 2. Yes, there we go. Let's go, guys. Alright. Now all you have to do is, here, let's just check this out. So 5, and that's right. Floor, perfect. Exactly what we wanted. Nice. Okay. Now what we want to do is fix this guy. I'm gonna duplicate the washers or spacers as well, like this. And then now what we need to do is just add on the other gears. And then we'll be almost done, which is quite insane because I literally started this in the live stream. Like when the live stream started. Oh wait, hold on. So first of all I need to so these are the clockwise gears. Okay, this is actually counter. C clockwise. Okay, perfect. Now we gotta move this. Alright, like that. And then, alright, for the one person besides my alt account in this stream, just wanted to catch you up on what we're doing. We're just trying to make a fully 3D printed gearbox with minimal hardware, and it just uses like those cheap 608 like skateboard bearings. So this is actually a revision to my previous design, which is this guy. That's the shredder. If you're a subscriber to the channel, you might have seen some videos on it. But this guy's the gearbox, and it was like slightly faulty, not the best design. So here I'm just trying to update it, you know, and yeah, that's the goal. Yeah. Let's here, let me align this. So this guy needs to go to here, like so. Okay. And we need to align again. That guy to there. Perfect. Yeah, so we're definitely gonna need to work on like some tolerances and stuff afterwards, but that stuff I'll worry about later. Perfect. Oh, and right, just before I forget, I will do an offset. Oh, right. Yeah, I'm a little bit slow, but we need to do a cut first to like enable the shaft to, you know, go through the part. So yeah, I kind of messed up the timeline. Let us push all these over like that. Alright. Yeah, I don't want them to all be there. How about now? Okay, we can create a sketch right about here. And then we just need to project P for project. No, I'll just project these faces instead. Yep, like that. And we'll just E for cut, hide this, and just slice through the entire gear like this. So this is definitely optimized for 3D printing and such, because 3D printing is cool, and it's probably like one of the most efficient manufacturing processes out there, and it's also really accessible. So if you don't have a 3D printer, I would highly recommend getting one. Yeah, so here we need to offset, and I'll just do it. No, don't do that. Yeah. Like this, negative 0.2. We want to give some good clearance. Yeah, it's really important for having like parts that fit together essentially. So if you don't have clearance, then you're kind of screwed. me just select these. And Fusion 360 is quite powerful, so I enjoy using it. What is your experience in Fusion chat? If anyone wants to type that in, I'd love to hear your opinion. Alright, perfect. So now we got that modeled in. We can like eat these rectangular patterns. Perfect. Yeah, that's a lot of bodies. Probably need to clean that up somehow, but for now I think we're fine. Yeah. Okay, create another one of these, but this time we're gonna make it like 17. Yeah, there we go. And then this time we're just gonna try to align it. So capture, edit, Control A. Here, and then we're gonna send it straight to this guy. Oh, we flip it. No. Yeah. So we'll change the from there to there. Oh. Look. Yeah, there we go. That looks mighty fine. Oh my gosh, 5 people in the live stream. It's a new personal best for me. Second live stream of this channel, in fact. So I'd say we're doing pretty well. Wait a minute. Oh shoot. Yeah, that's not good. Okay, but it is what it is. I'll fix that. Like this. Now we're gonna send it 2. And yeah, there we go. Okay. Alright. How do we fix this? So I guess we can't do it like that then. We're gonna have to like alternate. Yeah, shoot. That sucks. Really does. But like, because, okay, so if you don't know what I'm talking about, basically, so say I drive this gear right here, this guy, I drive that and it turns this big gear, and this big gear turns the small gear, thus turning this gear, but then, so it's a 1, 2, 3 reduction, right? But it's like, the reduction is like pushing onto itself, so basically that's just gonna not do anything. It's gonna get stuck and locked up and stuff. So you're basically like asking for failure. So right now, how do we go about this? Well, we could keep moving these things down. Okay, so here. Let's see what we can do about it. So yeah, so now parametric modeling doesn't seem too attainable now. Here, we can check out some like 3D printed gearbox for like some minor inspiration. Let's Print had a pretty good one. Yeah, see, you have to like stagger them, and it's like kind of weird. like this guy, yeah, you definitely need to stagger them because otherwise they're just gonna like crash into each other, and you know that's definitely not what we want. This is another gearbox. Really interesting. Or we could just like take like an existing gearbox and just slap a pinion on it. To be honest, could definitely do that. But like, what's the fun in doing that? You know. All right. So, what to do? I'm probably just gonna delete all these rectangular patterns because, you know, this isn't seeming the best. Okay, so like the first two definitely work. Or no, they don't. Not at all. Yeah, okay, so I'm gonna need a lot more length on these. Okay, so I have a fix in mind, but yeah, it turned out way harder than I expected. So 240, so we'll give it another, say, 10 or 20, 60. We'll just make it 60. It's fine. We can do it. We're a slow computer. And then this guy, the square can go a lot longer. 55. So total length 53. So -4. I mean, no, sorry, -7. That's gonna be 46. And then we want to give 2 more, so 44. Alright, perfect. Now, all we have to do is just, you know, space things out. How do we do that? I'm actually not quite sure, but gotta do some quick brainstorming. Pen and paper is definitely super helpful. It extends up and goes there. And then this will drive this, and then drive this. Okay, I think I might have something, but not sure if it's gonna work. The only one way to find out though. Take this guy. Okay, so what we're gonna do, we're gonna put this guy upwards. Oh shoot. So can I move these two guys here? Alright, we can do it. I have an idea now. Edit, Control A, and we'll throw it here. No. And of course, like we can fix things up as we go along, which is the beauty of online stuff. So no need to worry about making mistakes. Alright, and now what we gotta do is we gotta make another one that extends all the way down. Yeah, so that was vague AF, but you guys can just watch me. So this time we want it to be counterclockwise, 17. Capture, Control A from here to here. Yep. Yeah, one quick tip. Oh, hi, Rando Tech Nerd. One quick tip for you guys when doing herringbone gears, which are basically dual helical gears, is you always want to make sure, they're like going the right way. You want to like make sure the arrows are either like the arrows, the arrows that they make. Okay, cool, random tech nerd. Anyways, you want to make sure the arrows are either pointing towards each other, like this, or away from each other. Oh yeah, and also a sneak peek at what I've done so far, Rando, if you're still here. This is like the next step up for the shredder. It's definitely 100% more polished, throw the logo on there as well. And stool shaft, it's a 1-to-1 ratio, but I've heard it isn't like the best because you want a varying speed for the two shafts, but it is what it is, right? So, I mean, obviously I can change it soon, but that's gonna definitely require some tinkering. Yeah, talk to you soon. But yeah. Okay, so back to where I was at. Capture position, so you can see they're pretty well meshed, and now we just need to have like a cylinder that runs all the way down. This is a little bit complicated, but here, why don't we just project this then? That's the thing about gears, they're quite complex as a shape, so like projecting them can, if your computer is like ever so slightly laggy, it really sucks. And I'm gonna join. Oh shoot! No, I don't want. I want to create a sketch on this guy. And then here. And then we can create a sketch, E for extrude, and bring that sucker all the way down to somewhere around here. It doesn't really matter too much because we're going to end up combining them, so any overlap will just like be like just combined away, so it's fine. Now this guy, and then we need 51. Alright, pretty cool. And wait, what just happened? Okay, I see it now. I'm a little bit slow. Well, no, we should be okay. Just gotta. Yeah, that's right. Always remember toggle in and out of where Control A. No. So this guy gotta move. Got a ton of aligning to do. It's kind of annoying. There must be an easier way to go about doing this, but I'm not too sure. Okay. And just... oh no, that is not what I wanted. Okay, Control A. Maybe let's try it like this. Okay, that might be it. Alright, there we go. That's what we were looking for. Finish position. So I think we need 1 mil less from this extrude. So 20. Almost there. Or was it? Oh, or 21 was right. Maybe I should just inspect because it's Fusion 360 and I can just inspect the length. Oh, 9 mils. So yeah, it should have been 20. And then whoops. Edit. Align. Take this and just chuck it here. Boom. Alright, good. Very good. And now we can theoretically rectangular pattern this now. Oh my gosh, 7 people. Wow. I'm famous. No, I'm not. I'm just kidding, everyone. But yeah, so this gearbox is looking pretty well, and now it doesn't like violate the laws of physics or something. Which, yeah, that was pretty immature of me to, do that. So now like the goal is to make everything work. All right. So we gotta do our cuts and stuff. We gotta do our combines. We gotta do like all the little details now. So to start off, we're gonna combine the gears because these need to just join together, and we also need to make some spacers for the spots that aren't that don't have gears, like here. So this can all join. And we want to remove the components that got combined away, if that makes any sense. Because in Fusion 360, right, when you combine something, especially if you're doing cross-component combining, each component, you can see there's a bodies folder. Like when you combine, the element of one component will go into the element of another, like the folder of another component. So it disappears essentially. But yeah, we are fine. So radius is 6.705. That's such a weird number. Okay. Alright, now we gotta just do some fixing up and stuff. So this is this is clockwise. Lock. Oh, I'm about to turn off caps lock. Clockwise. Gear 2 out of 3. And then this is now the C clockwise. 3 out of 3. Okay, perfect. And now we got some stuff to do. So for this guy first, let's make actually no, we don't need that. Never mind. Yeah, we're fine. Because theoretically it will be friction fit, and since these are self-aligning gears, we shouldn't need spacers or anything. but I'll probably create them just in case, actually. Yeah. Yeah, I'll do it. Just start project. Boom. Oh no, I do not want to join. I want to make a new body. Okay. And I should, while I'm at it, so gears, and then spacer. Okay. This guy. Gears. And we'll create the spacer as well. Alright. And then as for this guy, like 3D printing it in place should be okay, but I'm probably just gonna split it. So this guy, splitting tools here, here. Yeah, super laggy. I need a new computer, guys. Hopefully it doesn't crash. If it crashes, it sucks. Yep, it probably crashed. It's not responding. No. Oh, I didn't save. I'll just sit here and wait. Should I rage? Alright, for those of you that are watching, yo, both of my computers are tweaking out. Alright, so I started a poll. So if you guys want to answer that, here I'll edit it. Yeah, I'm gonna make a new one actually. Start a poll. Fusion crashed. Should I rage? There we go. So if you're watching, do me a favor and answer that poll. So unfortunately, we're gonna have to bro, why is it crashing? No. It's okay, guys. That was yeah, it was a good try. It's okay though. Yeah, so it's really annoying when Fusion 360 does that, but hopefully it created a recovery document which should theoretically make things recover everything. Alright, guys, answer the poll. I know there's like 4 of you guys here. There's 0 votes. Y'all gotta lock in. Oh, 3 people. Hey! And we want to open a recovery file. Yes! Thank you so much, Fusion. Thanks for saving my progress. Yes, perfect. Well, not super perfect, but we are back at least, and we're up and running. So that's all that matters. Well, you can't complete the extrusion because I didn't select. Okay. I would just try new component, and so here is just a spacer. Rename spacer. Alright, did I cut, shoot, it's grounded to parent. Unground. Perfect. Yeah, it's not cut yet, so we'll need to create a sketch. And then, okay, let's isolate. And then we just need to show this. Not extrude. We want to project. Alright, I'm gonna end the poll because it came back, and because of autosave, we were able to basically regain progress. Oh my gosh, 9 people. That's actually pretty sick. Honestly. That's a lot of people. Imagine just like 9 random people in a room just listening to you talk. That's quite nerve-wracking, isn't it? Okay, 6 now. We should probably, here, let's just save. Yeah, great idea. I want to move this guy a little bit further, but we shall unisolate and then do this stuff first. So we could definitely 3D print this all in one piece, but I think it's better to, split this guy into multiple pieces. So we can construct we can construct offset planes and then use these offset planes as cut planes to split this guy apart. Yep. Modify split body. This should theoretically not crash. Oh yes, it didn't crash. Yeah, it was probably only because it crashed earlier because like Fusion, it doesn't like working with super complex, like too many vertices and that type of stuff. So, thus it just decided to, what the freak, decide to crash on me. Yeah, so always remember that when you're working with gears, that you're always at mercy of Fusion 360. You can hide this. Just project. No. These faces. And then we can offset later to make it, make it fit together after manufacturing. Designing for manufacturing. It's very fun. And we cut. Make sure everything's right. And then we can re-show everything. Okay, perfect. Got some progress in. That's good. You can hide the construction. Now you can see that the gears, they don't defy the laws of basically physics because they don't like intersect each other. Yeah. Alright, so this is like a gearbox going pretty well. Definitely the spacers and like pretty much everything could use some work. But right now I'm just gonna move this offset, which I did a while back actually. Where is it? Here. I'm gonna move this off. No, I can't. Bruh. Okay, maybe. Okay. How about this? I move these rectangular patterns over all the way there. It's quite irritating actually having to clean up your design and doing all this stuff, but it is what it is. Slow computer, let's go. Alright. Okay. Yes, because we use it's like cross dependent. Okay. So we can't really do anything about it, so we'll just do a separate offset. Now, this obviously makes your design timeline a lot more messy, and you should refrain from being messy in general. But due to my lack of giving an F, I will proceed to just keep modeling. Yeah. I'll proceed to do it. Okay. I get point to type that in before I forget. Nice. It's funny, y'all, because I have like two computers running, and one of them's a Mac. It's an older computer, and the other one is a Windows. It's funny because the one I'm running the CAD on is like literally silent, and the one that I'm literally watching my own live stream on is it's it's really loud, so like you can hear the fan. Also, yeah, 9 minutes ago, y'all said I should rage. It's too bad, because Fusion 360 doesn't want me to rage, because it created a recovery file. I mean, like, so I didn't actually lose any work, if you think about it. So, if I rage now, it's gonna be, I'm gonna hurt Fusion 360's feelings. And that just looks weird, screaming. Alright, so what I'm doing now is hit a chamfer on this this shaft, because one thing I've noticed is sometimes my Bamboo printers, they tend to make the corners a little bit curved, and then like that makes it hard to like snap onto the shaft. So what I'm gonna do, I'm gonna hit like a 0.5 chamfer. Doesn't like weaken the structural integrity of it too much, but lets the assembly process go by a lot smoother. And that was a pun intended, because like when you slide it on, it's like smooth, right? It's not like getting stuck. Okay. Oh yes, now we have a bunch. Oh my gosh, I should have saw that coming. Because these extrudes have like a circular dependency. Yeah, I lied. I'm gonna delete that. And then now it's perfectly flat. It's kind of annoying because, especially working with parametric stuff, you have a good idea and then you do it and then it just messes stuff up. So you're gonna have to find a way to do that earlier. Yeah. Or I could just rectangular pattern the thing, but it's right now computing, so there's nothing we can do. I can start another poll actually. Actually, we're ending the poll. Sorry for the two of you, literally two of you, that that said I should rage, but answer questions. Favorite CAD program. Alright, y'all. This is your favorite CAD program. It's my you guys can answer viewer questions live. Like, you guys can just ask me stuff, I guess. Or whatever. I don't even know. Haha, I had to go with rage. I don't think you need to. Yeah, exactly. Cause yeah, no shame though, of course. You know, like everyone wants to be IShowSpeed, but probably not today. Maybe next time, cause I've only used Fusion or Onshape. Yeah, that's pretty reasonable. Okay, this is kind of annoying. Now I'm missing a profile. Isolate, please. Yeah, don't. Okay. Yeah, okay, so as I was saying, Onshape, Fusion, they're pretty nice, actually. A lot of people... Yeah, I'll be printing it. Yeah, 100%. So, here, let me catch you up or something. So, I'm right now working on this project called Operation Perpetual Printing, and it's like, I'm trying to make, like, shredders and that stuff for, like, easily made, because, like, a lot of shredders, like, a lot of the parts, especially, like, the panels and stuff, can be 3D printed, and, like, a lot of makers could really benefit off of it. So, it's, like, a semi/mostly 3D printed shredder. And like the gearbox, like if you have a shredder, you're gonna need a gearbox because obviously you want high torque, right, to shred things. So I guess the gearbox is to drive the shredder, but this is like a finished version, and I have yet to make a video on it, but it basically doesn't work, in short. So that's why I'm trying to just make a new one. I'm actually kind of confused what's going on with these errors. Yeah, I've only used Fusion or Onshape. Yeah, honestly, my first one was Tinkercad. That was my first one, and one of my favorites actually. It's quite a nice nice program. One thing about Tinkercad is quite interesting because they're like basically making it catch up to Fusion, because right now what they're doing is like they're adding a boat ton of features like sketches and stuff, and it's honestly really catching up to Fusion, which is like quite mind-blowing. So no hate on Tinkercad. Alright, we've hit the 69-minute mark. Yeah, actually, I don't mean to redirect you or anything from this live stream, but I made a video already on this channel, on like the 3D printing shredders and stuff. It's like pretty recent actually, so I'm sure you'll have no problem finding it. But yeah, like, so this channel called Let's Print actually did a shredder with 3D printed blades, and they actually held up fine. Because the thing is, like, even like PLA and PETG, you may think they sound quote unquote weak, right? But like compared to like it's like if you're putting enough force on it, they're actually able to shred. And if you have like multiple blades working with each other to shred something, they can produce pretty great effects. So yeah, So to answer your question, yeah, I will 3D print all, including the shredder blades. But like, it's also designed to be easily like CNC milled if I happen to use PCB ways like services or like some kind of like manufacturer to help me out. So yeah. Okay. Now we will configure the rectangular patterns, I believe. Yeah, right tolerances, infill setting. Yeah, they will definitely be strong enough to shred. I haven't gotten into shred yet because I haven't done the gearbox right yet. But yeah, definitely. Okay, so now we need to do rectangular pattern. Rectangular pattern. So these guys will go on this axis, and the spacing. So we want spacing. So whenever you do a rectangular pattern, a great tip is always like select this spacing thing so you have like a lot better control. So this one we want spacing. And we want it to be times 3. Times 3. So you can see like that. And then for the number, we want to do ceiling. So seal, and then it's like number of shaft number. So you can see, or no, shaft number divided by 2, or maybe 3. It's probably 3. Yeah, shaft number divided by 3. So gotta run to work. I'll keep the video playing. Yeah, appreciate it. I really appreciate the kind words. Yeah. Okay. Now you gotta hit another rectangular. And for this one, it's like the same exact thing, you know. These guys. I'm not sure why I set that as a component, but spacing, so spacing times 3. Times 3. And then this is seal number divided by 3. Well, actually, this is actually kind of interesting. Okay, so this, okay, the second, so right now we're looking at the second gear. We gotta do some math here, alright? The second gear, it occurs every, so it's the second, and then third, fourth, and then fifth, so 2, 3, so it's the second one, so 1, 2, 3, 4, 5, 6, 7, 8, so it's the second one, then 2, and then the fifth one, and then 2, and then 8th one. So it's in position 2, 5, and 8. So for 8, there's 3. Maybe we do 4. Actually, I have no idea what I'm doing, honestly. Guys, this is why we need real engineers in society. Because, you know. Number divided by 2. Or divide by 3. Yeah, okay. Let's change the parameters just to check. So 8. Let it calculate. Did it work? Yes. Wait, no, it did not. But why is... Oh my gosh, dude. Okay, so let me just fix this. I'm not sure why it makes like a new component. This is quite infuriating. Alright, well that's right. But I should have made this a body. Yeah, I definitely should have. Yeah, this is terrible. Guys, help me. Why did I do this? No worries, we will just go back and fix it. Like how I've been doing it for this entire time. Just making mistakes, falling down, getting back up, you know. It's gonna be alright. Okay, so did that. Alright, okay. And then that's the cut. Yeah, so why did the, can we just hit join? Oh my gosh. Bro, why? I want to delete this. Yeah, not sure what to do here, but so this is the spacer guy. We don't even want this. Why is this here? Yeah, so yeah, okay, that's perfectly fine. I do not want to. Okay, it's fine. We will just literally do the same thing, but make a new body. There's new body. This is why we don't do anything weird with our CAD. Oh, of course, there's goddamn downstream dependencies. Unsuppress. Or we could just do some really cringy work. What I'm concerned about is like, what is this? Why didn't it duplicate? Where did the gear go? Yeah, where did the... Yeah. Wait, what if we do cancel? Yeah, this is quite infuriating actually. So like in a sense this is like parametric modeling, but like at the same time, not really. To be like dead honest with you. So I'm gonna delete this. This is the massive like offset. Bro, I'm about to like start tearing my hair out for this. Oh. Now what is this? So this guy. Okay. Not bad. Just not in the right spot. Maybe that's it? Nope. Yeah, no. This is not it. Yo, where did I... deep breaths. No one understands the struggle. Literally no one understands. It's like the Fusion 360 struggle. Alright, now we can try a rectangular pattern, but this time with bodies. Here. Here, let me... Bro, no. Shoot. I messed it up yet again. I'm not even surprised though. To object. Body. Okay, we're chilling. Alright, now that should have done it. Yeah, I literally have the ugliest timeline in history. Oh, wait, that worked, guys. That literally worked. We have 3 of the, wait. What am I? Hold up. No, that's the first gear's rectangular pattern. Oh, we haven't done the offsets yet either, so I should do that first. Shift O. Want to hide these. And I'm pretty sure it's just these guys. Right. Angle point 2. And we just need to like check our work by just clicking on these lines. 8.4. Bro, what is that sketch there? Okay. 8.4. Let's go. Let's go, guys. Alright, I'm gonna get a drink of water, so... is it possible to, like... Yeah, I'll be back. Just give me a sec. Okay. We are back. Alright, now we gotta do rectangular pattern for some other thingies. These are the last ones. And then this guy. So we want this axis. Spacing. Distance is spacing times 3. And then whoa. Yeah, there we go. There we go. It's not too bad to cooperate, isn't it? And then for this, it's like shaft number. Divided by 3. It's either floor or steel. I don't know. like coating in a sense. Pretty cool. No, it's probably ceiling. Or it's floor. Okay. And then we just need a rectangular pattern. Wait. Nope. Now, do we rectangular pattern this guy yet? Not yet. And then, obviously, it's the same. Now, I'm assuming the quantity is like 4. Number of shafts divided by 3. Or it could be ceiling for this one. I really am not very sure. Probably gotta like look into this math. There's definitely like a way to like write it out as a formula. But yeah. Shout out to my big brother who gave me an idea for this design. Because like overall it's like a lot more straightforward to implement, especially like making it parametric. So yeah, good on him for thinking about this. Alright, you can see, looks pretty good. Now, definitely just gotta save. You want to save it, you know. Now we want to create the base. So that's pretty straightforward. In fact, it's probably the easiest part of this entire process. So we hop here, and again, we're trying to make this as parametric as possible, so it should update. We're going to create a rectangle, and we want to make sure the gears don't like touch the ground or anything. Like this. And then we want to fix one end, so it's fix on fix, alright? And we want to fix, yeah, that's right. We want to make, I'm assuming these are already constrained, yep. Okay, so the dimensions of this will be the spacing times the number, something like this. It'll be like, it'll have a relationship to this. And then we will probably do like times like 1.25. Again, there's definitely like a formula for this, but I'm just trying to figure out the quickest way to get this done, like 1.1 maybe. Okay, there. And then all we gotta do is hit C, and then 22 for 608 bearings. Alright. And we're just creating a rectangular pattern, spacing, and then number. So quantity and shaft number. And the spacing is just spacing. There we go. And then you can see it's quite straightforward here. We just want to hit an extrude and extrude this way, like I think it's like 7. Like that. Now, of course, unless you have like a Prusa Excel, you're not gonna be able to print a 300.52 millimeter object. But I mean, if you do, good for you, right? Yeah, I'm jealous. I'm gonna steal your Excel. But let's just test it real quick. Instead of 8, because let's say we want 3 to the power of 3, so that's 81. 81 times 3, that will be 243. 1 to 243 reduction, so just 4 shafts. Yeah, my math ain't the best, but okay, so gave me some extra stuff, but you can see it adapted pretty well. Okay, so Also, ChatGPT will be involved in doing some math because gotta utilize your resources. Shout out to my math teacher because I'm not good at math. Just kidding. Yeah, this might be floor. Just leave it as floor. Okay. So this is what we have so far. Let's hit save. And then let's, for the base, just create another, wait here, let me just check height. 50, that's not a lot. This profile, so we're taking the same profile, making it as parametric as possible from this object, and we hit 7. It should theoretically be a new body. I don't want to join with anything quite yet. But yeah, that's looking pretty mighty fine good. Then these will get sandwiched together and yada yada yada. And should be good. Alright, so it's been quite a while since I've started streaming, so I'm probably gonna, end it here. But yeah, that's like essentially how I make my things, my models and stuff. As you can see, it's really disorganized, but especially if you don't have an idea in mind at first, it can be super hard to organize it. So there's a chance I might go back and remodel this, but with top tier organization and stuff. But for me, from where I'm at, as long as it works, then it works. So that's basically my priority. So yeah, thank you very much for watching and staying with me for this entire time, for those of you that are here. And I'm gonna end the stream now. Alright, bye.